Hey guys, today we're going to be learning about probability. Let's define a few different words that you're going to hear me say a lot. So we're going to define those so you know what we're talking about here, and then we're going to try some probability questions out. So to start with, let's look at what an experiment is. An experiment is an activity involving chance in which results are observed. So I have this dice here. And an experiment would be me rolling the dice. There are 6 sides to this dice, and it involves chance because we don't control what number this dice is going to land on. And then we would roll it once, and we would look and see what it landed on. So I'm going to try rolling it, and I land on a 3. So that's where you're observing what results you get. A trial is each observation of an experiment. So like I just got a 3. If I tried it again, that would be like my next observation. So that would be a second trial. And outcome is each result. So on this dice, there are 6 different outcomes. 1, 2, 3, 4, 5, 6. Because those are the different types of results you can get. An event is a set of 1 or more outcomes. And then probability. The probability measures the likelihood that an event will occur. So probability can be seen in a lot of different places out in the real world. You can think of looking at your weather app. If you look at the weather, it may say, okay, we have a 50% chance of rain. Well, the odds that it's going to rain is half. Okay, 50% chance it might rain, 50% chance it might not rain. Now I'm looking at my weather app right now, and for 7 o'clock it's showing that there's a 15% chance of rain. So there's a chance that it could rain, but it's not very likely. Alright, and then sample space. The set of all possible outcomes for an event. And so that kind of goes hand in hand for outcomes. Like I said with the dice, the sample space for the dice is 1, 2, 3, 4, 5, 6. If I had a coin, the sample space would be heads and tails. So let's fill that in here. The sample space for a dice would be 1 through 6 for each side on a dice. And then a coin has heads and tails. So with probability, we talked about weather. The biggest place that you could find probability might be like the casinos. You have odds on if you'll win or not. Those games are based off of probability, and honestly, they make it to where you're not going to win. You're not going to win as many times as you would lose. Alright, so we have this number line here that talks about the different types of words that could be associated with probability. If something is 0% of a chance, it's impossible. So I have this deck of cards here. It's a normal deck. Some of the cards are red, and some of the cards are black. The odds that I randomly pick a card and it is purple is impossible because there are no purple cards in this deck. Unlikely is in between 0 and 50%. It's very low. Like I said a minute ago, the chance of rain right now for me is 15%. So it's unlikely that it's going to rain, but not impossible. It could rain. 50% means as likely as not. So let's talk about coin. We have heads and tails on a coin. As likely as not, so I could flip heads or I could flip tails, and that's a half chance for each because there's only 2 sides to the coin. Likely is somewhere in between 50 and 100%. It's not certain, like 100%, but it could happen. We could expect something to happen if it's likely. And then, of course, certain is 100% chance, without a doubt. If I talk about this deck of cards here, Without a doubt, I'm certain that I would choose either a red or black card. Alright, so let's look at this first one here. There are 2 red queens in a standard deck of 52 cards. What is the probability of getting a red queen if you pick a card at random? So when finding the probability, we're going to make a fraction. The total outcomes will go in the denominator, and then whatever the question is asking for goes in the numerator. So let's read it a little bit slower and highlight important information. I see that we have 2 red queens in a standard deck of cards, and there are 52 cards in that deck. What is the probability of getting a red queen if you pick a card at random? So they're all mixed up. We're going to close our eyes, we're going to choose a card, and figure out the probability of selecting a red queen. Well, the question's asking for a queen, and we know that there are 2 red queens. So the numerator from the question is 2. And then the denominator is the total outcomes. Well, there's 52 different cards in that deck. So we're going to put that over 52. Now, if this were a test question, I almost guarantee you're not going to find that answer there. You always need to check, can we simplify? We can. Both of these numbers are even. They both end with a 2, so I know that I can divide by 2 on each one. 2 divided by 2 is 1. And then we're going to do 52 divided by 2. 2 goes into 5 twice. Minus 4 is 1. Bring down the 2. 2 goes into 12 6 times. Okay, so the odds of selecting a red queen is 1 out of 26. And then the next question says, what is the complement? So instead of us writing a definition for the word complement, we're just going to go off of what this question says. Complement is the odds of not getting the red card, and more specifically, getting the red queen from the previous question. Complement means the opposite, or not. So if the odds of getting a red queen was 2 out of 52, the odds of not getting a red queen would be the total number of cards, 52, minus those 2 red queens that we know are there. There are 50 cards that are not red queens. So this is what the question's asking for. So we're going to go back to our fraction. The question goes in the numerator, and the question's asking for not a red queen, which there are 50 cards. If I were to take these cards and count them, I would find 50 cards that are not a red queen, and there are 2 red queens that we would count out of this deck. So 50 out of the total outcomes, which is 52. Again, if this was a test question, you probably would not find this answer there. Both of these are even, so let's divide by 2. I know they're even because of this 2 here. And if a number ends with 0, it's even. So 50 divided by 2 is 25. And then we already did 52 divided by 2, which was 26. So the odds of not getting a red queen is 25 out of 26. Our answer of getting a red queen is 1 out of 26. I want to show you this trick also. 1 plus 25 is 26. So if you add those up, they end up adding up to a whole. Alright, spinner activity. We're going to play a little game called Would You Rather. We're going to choose the option with the best odds. So would we rather land on an even number on the spinner, or land on a number that is either 1, 2, or 3? So to land on an even number, let's look at it. There's 2, 4, 6, 8, 10. That is 5 different sections out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total. And then to land on a number 1 through 3, well, that's 1, 2, 3 sections out of 10 total. Which one would we rather do? Which one gives us the greater odds? I would say landing on an even number. There are more spaces, and if you notice, 5/10 is greater than 3/10, so it's a greater chance of us getting an even number than a 1, 2, or 3. Okay, let's try the next one. Would we rather land on a color not related to Christmas, or land on a Christmas color? Okay, Christmas colors might be this red. It could be this green. Some people might think yellow. Okay, so Christmas colors, let's say that that's 3 of them. Actually, you know what? Some people would say white for snow. So there are 4 Christmas colors out of 10 total sections. Not Christmas colors would be all these others. 1, 2, 3, 4, 5, 6 out of 10. So which one would we rather do? Well, I think there's more colors that aren't necessarily related to Christmas, so not Christmas colors. Since there are more of them, we would have a higher chance of landing on a color not really related to Christmas. Alright, would we rather land on a 0 or land on a 4? Well, not seeing any zeros, so the probability of landing on a 0, since there's none of those, it'd be 0 out of 10 spaces, so this really is impossible. Landing on a 4, well, there is a 4, so that would be 1 out of 10 total spaces, so I would say landing on a 4. At least you have a chance to land on a 4. Because there are no chances to land on a 0. Okay guys, that's probability. Whatever the question's asking for, remember, will go in the numerator. So the question goes in the numerator and the total outcomes go in the denominator. Set that fraction up. More than likely you need to check if it can be simplified. If they're even, divide by 2, or sometimes we will divide by 3 or another number. So make sure you do simplify on these. And remember, probability is the odds that something will happen. So it's like rolling a dice, flipping a coin, the weather, the odds that it might be raining or not raining. Remember, games at the casino are all based on chance. Thank you guys for watching.